welcome back to another LeetCode problem solving video. Today we are solving another very interesting problem using C++. So the problem name is isomorphic strings. So in this problem we are given two strings S and T, and our task is to determine whether these two strings are isomorphic or not. Now the word isomorphic may sound complicated, but the idea is actually very simple. Two strings are called isomorphic if characters from one string can be replaced to get the another string. But there are two important conditions. So the first one is every character must map to only one character, and second is two different characters cannot map to the same character. So basically the mapping must be 1 to 1. Let's understand this with example. Suppose S equals to egg, T equals to ed. Now let's compare character by character. E maps to A, G maps to D, G maps to, and the second G also maps to D. So everything is consistent. So these strings are isomorphic. Now take another example. S equals to F00, T equals to, S equals to F11, T equals to B23. So F maps to B, 1 maps to 2 and 1 maps to 3. But later, now since 1 maps to 2 and also 1 maps to 3, so 1 is mapping two different numbers, so it won't be isomorphic. So this is invalid. Now before coding, let's think about the logic. So the main idea is while traversing both strings together, we store the mapping between characters. We need to check two things. First, whether a character from S always maps to the same character in T. Second, whether a character from T always maps back to the same character in S. That means we need two hash maps. One map for S to T and another map for T to S. This ensures 1-to-1 mapping. Now let's start coding step by step. First, we create two unordered maps. So let us create the first map stores mapping from S to T, the second map stores mapping from T to S. Now we traverse both strings together. So at every index, we compare characters from both strings. Now first, we check whether the character from S already exists in the map. So we will use if condition. If frequency.count of S of I and end frequency of S of I. Sorry, here little mistake. We will use C of I not equals to T of I. Then return false. Now let's understand this carefully. Suppose S of I equals to A. If A is already mapped to some character, then it must always map to the same character. If not, the strings are not isomorphic. So we return false immediately. Now similarly, we check reverse mapping. So if frequency 1.count T of I and then frequency 1, sorry here little mistake in spelling, of t of I not equals to s of I. Okay, then here also we will return false. These conditions ensures that two different characters from S do not map to the same character in T. Again, if the mapping becomes inconsistent, we return false. Now if both conditions are valid, we store the mappings. So frequency of S of I will be equals to T of I, and frequency 1 sorry one of T of I equals to S of I, and then continue traversing the strings. Finally, if the loop completes successfully, that means every mapping is valid. So we return true. So therefore, after completing the loop, we will return true. Okay. Now let's understand this properly with a dry run. Suppose S equals to egg, T equals to add. Initially both maps are empty. Now start traversing. Index 0. E maps to A. Let's see in the example. So here E maps to A. Store E to A and A to E. Now index 1. G maps to D. Store G to D and D to G. Now index 2. G maps to D. Check existing mapping. Is it already consistent? So continue. Loop finishes successfully. Therefore we return true. Now let's take another example. Suppose F11 S equals to F11, T equals to B23. Index 0, F to B, valid. Index 1, 1 to 2, valid. Index 2, 1 tries to map to 3. But previously 1 was already mapped to 2. Now mapping becomes inconsistent. So we immediately return false. Now let's see the code is running properly or not. First of all, run it to check whether there is any syntax error or not. Then after we will submit it. Oh yeah, running helps in checking the syntax problem without, so that we can't fail the submissions. So let us also submit it to check that it is passing all the test cases or not. Okay, so it is passing all the test cases. Now let's talk about complexity. So the time complexity is order of n because we traverse the strings only once, and the space complexity is also order of n because in the worst case we may store mappings for all characters. So this solution is efficient and easy to understand, and that's for this problem. If you find this explanation helpful, make sure to like this video, subscribe to the channel, and I will see you in the next one. And if you have any kind of doubt, then please comment it in the comment section. I will try to solve it as soon as possible. Thank you.